Hi, my name's Mike, and I'm from the Fayetteville Free Library's Fab Lab. This training video will cover the MakerBot Replicator 2 3D printer, and upon completion of the video, you'll want to take our online quiz so that you can become certified. The 3D printer here runs off of PLA plastic, and it comes on the form of a spool that's just found on the back. This spool is only has about a quarter of the way left, a little less actually. So there's not much left, but a normal roll will have 1,000 grams or 1 kilogram of material. And this PLA is a bioplastic that's made up of corn sugars and corn starches, and it comes in all these different colors. Now we don't change the rolls out on demand based upon color requests because it does have a shelf life of about 2 weeks. As we kind of move up here, there's going to be a guide tube, and that guide tube, that clear guide tube there, helps to guide the PLA plastic into what's called the extruder. And the extruder is pretty much just a hot glue gun on tracks, really, on an X and Y axis track. What that's going to do is the plastic is going to come down into that extruder, and it's going to be fed in through a stepper motor and then heated so that it can come out that nozzle right there. Now this is an important part. Don't touch this nozzle. It's around 230 degrees Celsius and it's about 450-60 degrees Fahrenheit. So it's very, very hot, so do not touch that surface. Now where does the plastic go? Well, the plastic's going to go onto what's called a build plate. This is the build plate here. And here in the Fab Lab we have a couple different types of build plates. This one here is a metal machined build plate, and we do have some that are acrylic. One thing to note when you're using this build plate here, you'll want to make sure that you don't use any metal scrapers on removing the parts from these machines, and they have the markings listed on the machines. Instead, what you'll want to do is to either use a plastic scraper, or you'll actually just be able to twist the plate and it'll release your print. And I'll show you that in a little bit. One of the other things you'll note is that the machine has a letter and number corresponding to it, and this is to help with identifying parts that are printed from the machine and then tagged. Now tagging is actually a form that you'll fill out if you are leaving the Fab Lab while your 3D print is running. So you don't have to stick around for the entire print, but we do ask that you stick around for at least the first 5 to 10 minutes to watch that first layer go down on your print. And we'll talk about that a little bit more. But on this form, you'll just fill out a name, phone number, description, the date, and the machine number. So in this case, we would be using R2, and we would place that just right there next to the machine number. Don't worry about the cost. We'll factor that out after. Now, cost does work out to be 5 cents per gram of plastic, and we measure that up after the print has been completed and including any support or raft material. We'll talk about the rafts and supports in a little bit. So once you've filled out that form, what you'll want to do is you'll want to pass it along to one of the staff members at the Fab Lab, at the help desk, usually just behind you here. Now this form can be found usually next to one of the replicator machines, and you'll see them across our Fab Lab. Now in the Fab Lab we do have 7 of these machines, and there's usually a 3D printer form with every cluster of them. So let's just take a look at some of the possibilities that this printer can perform. Now when you're looking at these parts, one thing to take note of is that everything is being built in layers. So we take a look at this it's called a manifold. We take a look at this file here, and it printed in that orientation like this. And as you can see, there are these layers, these gaps, and this has actually been done on one of the lowest settings that this printer will do. Lowest setting meaning resolution. So the clarity or the grain on this is fairly coarse, and you can achieve much better finer prints, and we'll show you how when you're in the MakerBot software. But it's going to be starting from the bottom, and that nozzle is going to be moving side to side, and it's just going to be laying down plastic at the bottom layer. And every layer that it finishes the build plate will move down and eventually create your 3D file. So some files are static, they don't move. Some can be flexible, like this. Some actually have like ball joints so they can articulate. Some will actually have hinges printed. So this was actually printing just like that. You can of course assemble pieces, whether through glue or nut and bolt. Pieces will also work with each other, like this nut and bolt. Actually, they'll thread onto each other. And then sometimes parts will actually come with a raft material. So the raft material is like this disc of plastic that's kind of supporting or holding on to this iPhone case. And this disc of plastic, this raft, this is disposable, but it helps to keep parts flat. So it's going to help prevent warping. And warping is usually a problem. We prefer that a raft is used. And on this model here, this is a pretty old model. This one here, we could see quite a bit of warping. And this warping was due to the fact that a raft was not used, and this wouldn't be, desirable for your print. However, this is a successful print; it didn't fail. But a lot of times, when you get that type of warping, you're actually going to see the print fail. So let's talk about how to actually obtain a file for 3D printing. There are two different file types that we'll want to obtain for printing. You can look for either an STL, that's .stl file format, and it's stereolithography, and that one there is probably our preferred file format. You can actually find .obj files as well, and those will work with the software. These file types can either be created, downloaded, or scanned. When we look at the computer here, we'll see that our desktop is arranged in these 5 different areas. And we really want to take a look at the 3D design apps and 3D printer app and the help utilities. Now, if you want to scan something, we do have what's called a MakerBot digitizer. That is available. And that software there will be found under this link here. And it's pretty self-explanatory. However, there are some better alternatives for 3D scanning. Another alternative for 3D scanning is an app called 123D Catch. And that you can use either through the web, through Apple devices, or through Android. In these 3D design apps, we do have Tinkercad, we have FreeCAD, SketchUp, Blender, and we do have an industry standard one, SolidWorks, which is a lot like AutoCAD. So this is more of a professional level, but Tinkercad would be probably the base one, the one that you would want to start off with. It's a browser-based program. You just you don't have to download anything. You just go to tinkercad.com, you log in, and you can create there, and your files are saved. Come here to the Fab Lab, log in, and your Tinkercad account will have all the files that you've made. You could just download and print from here. So the other way to obtain one of these STL files is to download them. And one resource that most patrons use is a website called Thingiverse. You want to check that out. Thingiverse is a collection of STL and OBJ files that are for 3D printing that have been uploaded and created by users from all over. So with that, anybody can upload files, and that means that there may be an engineer, a hobbyist, or it could be a young child that has very little experience in 3D design. So your file may or may not work. Let's just take a look here and click on the Explore button. Click on Things. When we're looking at files here, just be aware of files that are in this computer graphic kind of representation. It's not that they can't be printed, but you'll really want to look for files that have true pictures uploaded to them. These are all kind of like Facebook pages. And by looking at one like this, it just means that the user has not uploaded a picture of that object being printed. So it may or may not work. Once you go onto a file here, you can take a look at it, click download this thing, and you'll have your STL. When you usually download files from Thingiverse, you're going to have them go into the downloads folder. What you can do is just open up MakerBot Desktop. And here we'll see a screen of a visual representation of our build platform, the limits of our machine, which are about 6 inches high, about 11 inches wide, and about 6 inches front and back. So it's a fairly big area. There's the front of the machine with this little pointer. Let's add our file that we had either downloaded, created, or scanned. And to do that, we're going to take a look along this grayish bar where it says Untitled, and we'll follow that along. You can see here that it says Settings, Add File, Preview, Export, and Print. Let's click on Add File. So this is where you would want to navigate to the Downloads folder. And this is most likely where that file will be that you've downloaded from Thingiverse. We're going to pick one that's on the web or on our desktop here for our practice. Here's our file. And now using the mouse, think of it with 3 different tools. You have your right mouse button, your scroll wheel, and then your left mouse button. Now your right mouse button is always going to be the rotate tool. So you press it down, hold it, and move your mouse, and you'll start to move around in 3D. Now the scroll wheel, if we scroll in or out, will allow us to zoom in and out. And if we press the scroll wheel down as if it was a button, and press and hold that, and now move the mouse, we actually do what's called panning. So we're actually moving the entire platform around. So that helps so that we can zoom in at a lower portion or another portion of our file. Now the left mouse button, that's going to be whatever is highlighted here along this left hand side. So you could always remember the left button always does what's highlighted here on the left side of the software. We have change view, move, rotate, and scale. Now this file here has come in, and this is great. This is perfect for 3D printing. It's flat, doesn't have any overhanging features. Okay. So this could print just like this. But not every file is going to look like this when it comes in. So what might it look like? Well, it could look like this. So now we take a look at that. This would not be suitable for printing. Why? This is because, well, if the plastic was coming out of the nozzle and it's starting at the bottom, right here, as it's printing this ring, it's going to eventually start to print this portion of the F. Now that F is just hanging in thin air, and that plastic is coming out a lot like gelatin. So it's coming out like a gel, and it's just going to try and cool in thin air, which is impossible. Now we could theoretically print with what's called support columns, but that wouldn't be the way that we want to print this. So this would require kind of flipping and turning and using some of these tools over here. So let's try and take this file that I've kind of twisted here and bring it back to a flat orientation. So let's try and use the move tool. If I click once, I could go and move the object on the platform, which is great, but it doesn't really help me with laying this flat. Now one neat thing that's kind of hidden is over on each tool. If you click on it one more time after it's been turned red, you're going to see a little flyout menu. We got a couple different variabilities here that we could type in: the X position, Y position, Z position. We want it to be on platform, and we want it to be centered, usually. Okay, but it's still not helping us with changing that layout. We need to lay this flat. So let's take a look at the turn or rotate tool. We click on this. If I click on it once, I could click and drag on my part, but it's just going to spin it around on the platform. And again, it's not turning it in the right manner that we need. So let's see if we could use this tool again. Let's click again to get the fly out options here. And now let's see if we could lay flat. Well, lay flat didn't work. We need to rotate it so that the computer can figure out a little more clearly what is the bottom and what's the top. And we can see that we're rotating in all different directions here. So let's try and maneuver this around so that we can get this to lay flat. Now, unfortunately, that button, lay flat, doesn't really work in the way that we would think usually. So here we have it, and it's still kind of tipped a little bit. Let's see if we can continue to rotate it here. There we go. There we go. So now we've made this flat once again. Okay, so now that we have this flat again, what we want to do is let's check out that scale tool over here. If we click it once, it turns red, and now if I use that left mouse button, click and hold, I could zoom in or change the scale on it so it's as if it's zooming in, and change the size of that print. Remember though, you want to stay within the confines of that gray platform. So right now we're too large for that platform. What we could do though, we could rotate it on the build platform here so that it would fit. And you can also use a shortcut, which is Control and L. So when we do Control L, it'll help the layout. A lot of times it'll center the item and twist it for you. So Control L helps to do that auto layout. Let's go back to scale and use it with that flyout menu. So if it's not there, click again after it turns red. Now we can change the dimensions of it in the X, Y, and Z axes. And we can also change the scale to as a factor of 100. So if we wanted to half the size of this, we could type in 50 and it'll take 50%. Sometimes when you have your object here and it's not selected, when you go and click a tool and you use that flyout menu, you'll notice that it says that there's no object selected. Whenever that happens, just go ahead and click on the object. Now let's say we wanted to add more than one thing to this plate, and we can. All we'd have to do is go to Add File, and we could bring in a whole nother file. It doesn't have to be the same one, but we could just go and bring in another file. Now when that comes in, you could see, well, they're on top of each other, and being on top of each other would mean that they become one as it's printed. So again, use that Control L button, and it'll do a proper layout for you that it finds fastest. This looks good. What we can also do is just select something, hit the delete key, and it will remove it. Let's do Control L again. Centers it. All right, this looks like it's ready to print. So will you always have to use these tools? Not always. Sometimes the files come in just right, and this one did originally, but we had twisted it just to show some of those tools. So now what's next? You always want to click on Settings. So after hitting that Settings tab, you'll want to go ahead and hit Quick. Quick is the one that we'll use, and we can find quality settings, there's raft supports. Let's start off with the best kind of practice. As soon as you open this up, go to Quality and click Standard. Then go and click Restore Defaults. That's going to set everything to its standard defaults, just in case somebody had messed with it prior to you coming and sitting down at the Fab Lab. Now quality, what does that mean? That's referring to those resolution layers, those layers that we saw in the parts. So standard is going to be a little cleaner than that part, and a little cleaner than that part there. We don't really recommend the high level of resolution, so just stick with standard. If you need something printed quick, go ahead and click low. Raft. Well, that raft that I had showed you earlier on this part here, that's just a disposable piece of material that just helps with that preventing warping. So we just want to make sure that that's check marked, and it already is check marked. It's recommended. It's the default setting. If anytime you switch off of a default setting, you'll find a little asterisk will pop up next to the value that's been changed. So that's a way to kind of warn you that something has been changed. Support material. We don't need support material on this, but supports are columns that the printer makes of plastic, the same type of plastic, that will help to prevent any kind of drooping of things that are unsupported. So if this keychain was sitting in the original orientation where it was kind of standing up on its end, we would definitely need supports. They're like bridge supports, but we don't need them in this case. Infill. That's set at 10%, and what that's referring to is a honeycomb structure that's actually inside all of these parts. We'll leave that at 10%. And then number of shelves that makes up the outside layers, the layers that you're actually touching. So there's 2 walls thick of solid material, and then it's going to be filled with 10% honeycomb. We're going to click OK. And now let's go up to the Preview tab. So the Print Preview gives you this nice little material use and print time report. We can see that it's about 4.7 grams of material. Remember, it's 5 cents per gram, and we'll round to the nearest whole number. Print time is going to be about 18 minutes for this part, and if we take a look at it, sure enough, we do have that raft material there now. We can also see the layers that it's going to build in. It's tough to see on the resolution of both of these screens here, but there we go. We can see some of those layers there. A cool little tool here. We can actually pull down and go through the layers, and we could look at that honeycomb that I was just talking about. We zoom in here. So there's the honeycomb structure. Those are the walls inside to help keep this rigid. Not too many, but it keeps it nice and light and structurally fairly rigid. Let's click on Print. What that's going to do now, that's going to move and send that file over to the printer. It's going to start to home the machine here, raise the bed. Now we put blue painter's tape on this printer bed. They don't need them, but it is preferred. We can help to apply that if you feel that the blue painter's tape is used up or torn. That nozzle is going to sit right there. You'll notice that the LEDs change to a blue tint. It's telling us that it is currently heating up. It needs to get to 230 degrees Celsius, and it's right around 37 degrees Celsius right now. If you have not seen this kind of action happening at the printer, usually means that we aren't connected via the USB cord. So you want to check the front of your machine and just to see if you have the USB cord plugged in to the printer. So we're going to wait here while this heats up. It'll take a couple minutes. We're at 100 degrees already. Okay, we're just about there. There we go. So why do you want to stick around? You want to make sure that the printer starts laying down plastic before you leave. So by making sure that it's laying down plastic, and usually waiting until this first layer or this raft is completed, then we're pretty sure that it's going to stay working while you're gone. So in the meantime, as you're waiting here, fill out one of those forms and keep an eye on that print. So there's the raft coming down. Let me see if I can find a better angle. And that raft is just at the bottom layer of that disposable raft that will eventually peel off once it's all done, but it helps to anchor that to the build platform. Taking a look at the computer again, we'll see that there's a Replicator 2 taskbar down here, and it says print 9%. In the bottom right hand corner, if I go and click on monitor, get a little panel that pops up. We can see the elapsed time is 3 minutes. It's about 10% done. This will eventually calculate out estimated time and filament usage. but that's another way to show the progress. Now, if something was happening, let's say plastic was not coming out of the printer, or the plastic was not sticking to the plate and it was following the nozzle, you want to open up that monitor and click cancel. Cancel will stop this from printing, but we can see here it's printing nice, so we're good. So what can happen when prints don't stick to the platform? Here's an example of a print where half of it was stuck to the platform and the other half really wasn't, but it's still kind of completed. So this would be something, this is why we tell you to wait around for that first layer to go down, the first couple minutes, because we would have seen that this had broken free from the build platform. Now this one here is on there nice and strong, but the other part of this nut and bolt is clearly hasn't printed well. Okay, so we're just about done. It's 99%. There we go. So once it's done, it's going to lower the build platform. It's going to put the nozzle, the hot end, back in the back corner. Again, be careful because it's hot, so don't touch the nozzle. Alright, so here's our print. Now, with this build platform, what you'll want to do is you want to lift the metal build platform right here. You'll see that there's a little relief right back there. You want to lift that up here, and it just is magnetized. You take that off. Alright, so now we could go and see if our part will come off. We can use either the plastic scraper as well, or you can actually twist the platform. So let's do that. Okay, so we're going to take that platform, there it is, give it a little twist, back and forth, just kind of twist it, see if we can get this off now. Still in there a little bit, use that plastic scraper, there you go, now your part's coming off. Now that your part is off, what we'll do is just make sure that we take that little, this is a little test line, make sure that that's gone. Take that metal platform, and in this case we just want to lay this down. It's going to be magnetized, so it's just going to snap down. Make sure it's kind of square on there. You can slide it on there. That's good. On other machines, the build platform's an acrylic platform, and it's this one here. It's clear and it's got blue painter's tape again on top. But one thing is that when you want to remove parts, you can use a metal scraper. Just be careful. If you need assistance, always ask one of the Fab Lab staff members. To remove the platform, though, there is a little tab back here that's holding on to the platform, and then two in the front. Now, these two in the front don't move, but the one in the back does. So a lot of times what I'll do is I'll take 3 or 4 fingers, put it underneath the platform, kind of provide a little bit of up pressure on it, and I take my thumb and I just push that tab back, and the part will pop off, or the plate will pop off, and now we can go and use a scraper to take off whatever part was printed. To reapply this platform, take that notch, there's one notch in the back, there's more of a tab on the front of the platform. Take the notched portion, put it to the back of the machine, so that it goes right into that tab there, and then on the front, just push down, and it'll snap in. If at any point throughout the process you do have questions, you can always refer to our MakerBot instruction guide, and that's a bookmark that's available in the Fab Lab. When you first walk in, you'll see a large display, and they'll have a bunch of different bookmarks. This is the MakerBot instructions, walks through all the steps for you. We also have some troubleshooting tips on the back, and of course you can always ask a Fab Lab attendant. This now concludes the 3D printer certification. What you'll want to do now is click on the link and take the 3D printer quiz, and you are now certified.